All right, so now we're going to get into adding vectors. So I saw this right here. This is pretty much all that your book has, and I saw that, and I was like, that's pretty sad. So definitely going to need a little bit more on this. I'm going to describe a little bit what's going on here, and then show some actual examples because this is definitely some of the foundational stuff that you're going to need to understand. So say there's a car moving 1 kilometer this way and then 2 kilometers this way, and then you want to find his total displacement. In other words, well, just from his you just want to find not the total distance traveled, but if you just want to know if he started here, if you want to know how far he is from where he started, not figuring out the distance he traveled, because here the distance he traveled would be 1 kilometer plus 2 kilometers is 3 kilometers. If you want to know how far his initial position is from his final position, we call that displacement. You want to know that, you're going to add these vectors, okay? So you can look at this kind of like, again, this is going to be the x-axis, x, and right, and y. So let me see if I can select all this. Here we go. No, okay. All right, so now he's at position. So this red vector is 1 on the x-axis, and then the y vector is 2 on the, it is 2 kilometers on the y-axis, right? So, well, what do we know about the final vector? Well, we know its position on the x and y. We know its position right here is position here is 1, 2. That's cool. That's cool. We know that. But then let's say we want to know, well, we know how long this vector is. This blue vector is 2 kilometers long, and this vector right here is 1 kilometer long. So let's say we want to add these vectors, but we want to find out how long this vector is. Well, we've already done this before. This is, this is classic a squared plus b squared equals c squared, right? Now, and that's classic and standard for dealing with right triangles. We're going to be dealing with more than right triangles. We're going to deal with all sorts of vectors that we're going to be adding and calculating as we go along. So let me select all this. Let's see. All right, and get rid of this. All right, so let's go through some examples. All right, man travels 120 kilometers east and 160 kilometers north. So if we're calculating the resultant displacement, go through these same steps, and we get 200 kilometers just by finding the hypotenuse. All right, so now say we wanted to find the angle. Well, we've already done this before. We have to remember our good old friend SOHCAHTOA, and we can use any one of these numbers with their respective trig functions to find what this angle is. So here, in the example, using tangent, notice it's properly adjacent this time, as opposed to how it was wrong earlier. And you're going to use inverse tangent to get the angle, right? Okay. Now, here's this. I think this is fun. I'm going to use a couple of these PhET links. All right. So go to that link, come here, and actually here, let me show you PhET a little bit more. Give you an overview of what this is. PhET. All right. So if you come here to PhET, it has all these simulations for just all sorts of classes. And we're going to be using these pretty heavily uh, throughout the course. This one in particular is vector addition. I come here, I'm going to click on this one, equations. Click on this again. All right. So if I have this vector here, right? So notice this is D, and then it has this arrow that's letting you know it's a vector and not a scalar, and we'll get into that a little bit more later. Well, actually, here, I'll skip the Reader's Digest version on this. So a scalar is just a value, right? So I'm having trouble thinking of what a good scalar is. Weight, yeah. So let's go with speed. Speed is just how fast you're going. Okay, not talking about any direction or anything. It's just speed. Now, velocity is your speed, but in which direction you're going. And value with the direction is a vector. A value without a direction is a scalar. So vectors are denoted by these little arrows on top. So if we come up here, you can see this. So then this is saying the D vector is 1 unit, or actually, yeah. Okay, so 1D. Okay. This, if I click here, okay, actually 5. Yeah, sorry. Okay, so sorry, blame my last. Look up here. Okay, so here's D. Right. So if I'm got D right here, we know that it's 5 on the x-axis. So we see that its length, its overall length is 5. Okay. This shows us its angle. Well, what angle is D? D is 0. It's just right flat against the x-axis. So, and then right here we have D sub x equals 5 and D sub y equals 0. What does that mean? Okay, well that means the x position of D is 5, right? Which makes sense. It's going 5 over right in the x-axis, and well then what's its y? What would that be? 0, because it's not in any direction in the y-axis. Now, okay, so now this is all D. If I click on E, boom, look at that. That's changing. So here, E, its overall length, here, its overall length is 8. All right. Is this not? That's where I used to be able to change these values. Okay. Oh. We have this, this. I'll have to play with this a little bit more. So when adding vectors, you go from where one ends. So here, this one starts at 0, ends at 5, and then this other vector here, you're going to pick up, it picks up where this one leaves off. So it's arrow to tell. So if we take this vector, this is the resultant vector of these two combined. Put that right there. Okay. So then what does this mean? Well, if we know that this vector, right here, yes, this vector is 5 in the x-axis. We know that this vector right here is 5 in the x-axis. And this vector right here, e, is 5.7. Okay, 5.7 in the x-axis. We're going to add the sub x right here with this sub x. Okay, so then 5 plus 5.7 is going to be 10.7. So this resultant vector is going to have an x component of 10.7. Let's look at this. So if I put this here, we see that it ends just before 11. So you can see that end right there. Ends just before 11. Okay, that's 10.7. Right. Then we know that the d vector has no y component, so we'll say 0. And we know that the e vector, its y component is 5.7. 0.5.7 is, click on this, 5.7. Makes sense. So then once we have the x, once we have the x component of this and the y component of it, we can look at this like a right triangle and then calculate, we can calculate this 20.8 using either one of the trigonometric functions that we wanted. There's some other. Okay, here we go. Oh, this is. Here we can build this. There we go. Let's say we want to add them together. We'll add this next one right here, and then we can play with it and then find out the angles. Not, this is what I was looking for the whole time. Okay, so yeah, so you guys can play with this right here. There's the 1D Explorer, the 2D Explorer, the equations. Here in 2D Explorer. There we go. Okay, so this one is A is 5 right here, A sub x, and it goes up to 2. Then we take B, so the the length, I'm just setting this right here so we can see. So the x component of b is 5 right here. So let's go 6. So the x component of b is 6, and the y component of b is 8, right? We can take this and we put it here. We can add 5 of a here. And the 6, so that's going to be 11. Let's get c. Okay, then that's going to be 11. Right? So then it's going to be 11, the x-axis. So let's do this. Let's make this 11. Okay, so that's 11. And then a in the y direction is 2. Okay. And then b in the y direction is 8. So that's 10. Let's keep this at 11 and make that 10. Okay. So then this vector, right, should be the sum of these two vectors. So let's test that. That here, and they meet up. Perfect. Perfect. So then, oh, okay. And then, so then once you calculate the x and the y properties of your resultant vector, if you wanted to, you can again use your trigonometric functions and calculate the angle right there. All right, so play with this. It's pretty fun. There are lots of other simulations on here that we will get to. And yeah. Oh, and next we will be getting into kinematics with Professor Dave again. So let me stop this, and that is all for this video.